Hi dear students, today we would be explaining about the experiment of the thin layer chromatography of ink samples. Usually thin layer chromatography is a chromatographic technique where you use a thin layer of silica as a stationary phase, and this silica has been placed on a glass plate and it serves as a stationary phase or the adsorbent. And onto this, what you do is you spot some samples, like the ink samples, and a mobile phase is also being used to separate the different components of the ink sample. Now, why do we have to separate ink samples using thin layer chromatography? First and foremost, you might have sometimes different queries. Sometimes you might have two different documents or questioned documents which has to be verified. So based upon the similarity of the ink samples, it might look similar, but you need to provide a genuine report saying that whether the two documents are genuine, or if the ink samples are the similar. So in such cases, what you have to do is you need to analyze the ink samples. And the technique which we use here is a thin layer chromatography. Now, what the basic principle bit of any chromatographic technique is mainly the separation of components based upon their polarity between the stationary phase, the solvent, and the component of the mixtures which are being studied over here. So if you take an ink sample, it will contain different components, and they get separated as they move along the stationary phase along with the solvent. A solvent or a mobile phase is used to carry the ink sample along the stationary phase. And as it moves, what happens? Based upon the affinity between the stationary phase and the mobile phase, the different components of the ink sample will move towards at different levels. And based upon this, we calculate a RF value. Okay, now what is RF value? You can see RF value is the distance traveled by the solute, or distance traveled by the solvent. Okay, there's a spell error. I'm just checking it. So how do we do this particular experiment? You need certain components. We need a chromatographic jar, a forceps, microcapillary tubes, scissors, TLC plates, suspect pens. Now, if you are having the suspects, their pens, as well as the evidence note is also being taken. And always you should wear safety goggles, wear the gloves and wash thoroughly with soap and water if you get solvent on you. Then what do? You prepare your developing chamber. I will show you a picture of the developing chamber later. So you take a developing chamber and add to that about 0.5 centimeter or 5 ml of your solvent. Now what is the solvent that you use? You can use different solvents, but now generally we use a mobile phase which has been made up of 60 is to 10 is to 20 is to 0.5 mixture of 1 butanol is to ethanol, water is to acetic acid. This is a mobile phase which is having different uh, liquids of different polarity, so that generally all the different components will get separated over here. Then, so this is a mobile phase. You took your developing chamber, and into that you will put 5 ml of this particular solvent. This is a solvent that we use. Okay, and at the same time you should also get a TLC plate, and you can get preformed TLC plates can be purchased from a supplier, or else you need to prepare a TLC plate. We will be discussing how to prepare it when we are doing it. So you take your TLC plate and you should not touch it with your fingers. You should wear a silica is not good. Silica is a bone breaker. So always when you're working with TLC, it's always good, like do not touch it directly. Wear a glove while you're using a silica plate, and then without touching the white silica, okay, and especially the side which you are using, you're not supposed to touch it. And with a pencil, use a ruler gently to draw a line about 1 to 1.5 centimeter from the bottom of the plate. And you do not chip off the silica layer also. And then you draw evenly spaced crosshairs across the, you can almost about 1 to 1.5 centimeter from the bottom, you draw a line, and you can spot the different samples at the on the particular plate. Now, what are the evidences that you have? Now, if you're getting an evidence, now for example, a piece of the evidence note, it contains about 2 to 3 centimeter of ink. So, you need to verify here, is the evidence note sample as well as the ink which has been obtained from the suspects the same. That's what we are going to verify. So, you cut a piece of the evidence note that contains approximately 2 to 3 centimeters of ink and place this piece of evidence into a small glass vial and add a bit of methanol, one drop at a time, until the ink is extracted from the paper. And this solution should be fairly dark enough, and try to use methanol as little as possible so that the solution becomes more and more concentrated. Now, the second thing what we have is the evidence ink. Okay, so immerse the capillary tube in the evidence ink solution until some liquid is drawn into the capillary, and very gently press the end of the capillary tube at the cross hair on the TLC plate. At the bottom of the TLC plate, you have marked about 1 centimeter above. You have drawn a line and you have spotted a cross-like thing for each and every sample. So you have to take one sample from the evidence, and using a capillary tube you have to place it that on one point, and at the next point you have to place the evidence ink also. And also spot the plate with the suspect inks. Using each suspect pen, gently make an ink dot and each crosshair on the TLC plate, and make sure that the ink does not touch each other. You should make sure that the different suspect inks as well as the evidence sample should be placed at different points. Now you have to develop the sample. What do you mean by developing the sample? Developing the sample means you have to take this TLC plate and place it in a developing chamber. The chamber which was already been pre-equilibrated with the what? Mobile phase. And you have to allow the samples, the ink samples, to move across the TLC plate until almost 3/4 of the plate is being covered. And after that, you have to take the glass plate and do not touch the jar or anything. Okay. Then after that, after the mobile face is moved across, you have to take the what? TLC plate outside. You remove the plate and you allow it to dry. And using the TLC plate, you have to draw what the plate looks like, and then you have to clean up, dispose all the liquids which are as per all the liquids which you have used. You, as per your instructors instructions, you have to remove everything, and you have to wash your hands with soap and water, and we'll see how a TLC plate will look like. Now, after the TLC has been done, you have to take each and every sample and you have to look the distance traveled by the sample and distance different traveled by the solvent and calculate the RF value. Now let's see how the plate looks like. So this is how it looks overall. You take your TLC plate, the silica plate, and you place it in a developing chamber. Before placing into the developing chamber, you take the plate and spot it at two different points with two different samples. And the samples should be placed in such a way that it should be above the mobile phase layer. Now here, this is a developing chamber with the mobile phase placed, and the spots of the ink sample should be placed above the level of the mobile phase. It should not, when you place the TLC plate, it should not be directly going and touching the mobile phase, because if it's directly touching, the whole samples will get mixed with each other. And also make sure that the two samples have been separated by some distance. And once you keep it in the developing chamber, you have to close it with a lid so that the developing chamber becomes saturated with the mobile phase which you are using. And during the process of development, the different components of the ink samples will get separated to different extent depending upon their affinities between the mobile phase and the adsorbent. And you have to do the experiment unless and until the ink sample or the solvent phase, sorry, not the ink sample, the solvent phase has reached almost 3/4 of the silica plate. Now here you can see two different distances over here. The B refers to the distance up to which the solvent has traveled. What is the solvent over here? The solvent is the one which you have taken in this or the mobile phase which you have taken in the developing chamber. We had told earlier 4 liquids which were being mixed together at a specific ratio. So the distance traveled by this mobile phase, that is referred to as B, and the distance traveled by different solutes, that is being marked as A. So for each component, you will calculate the RF value, the distance traveled by the component by the distance traveled by the solvent, and you will calculate the RF value. So if you have two different samples, now you will find one component has traveled so much distance. You will measure that distance, and that traveled by the distance traveled by the solvent, like that. For different ink samples, you will carry out RF values for different components which are being observed. At the same time, and you will record it in your analysis part. In some cases, you can take the TLC plate and you can just expose it under a UV light, and you can see that various other components which were not visible under the using a naked eye sometimes will be visible when they are being exposed to the UV light, because sometimes some fluorescent components which are present in the ink sample would be revealed when they get exposed to the UV light. So I hope you got an idea about how to do a TLC and how to analyze it. And by using the RF values calculated for each different ink sample, as well as the evidence sample, and as well as the UV exposure pattern of each ink sample, we can verify whether same ink is being used in an evidence sample as well as using from different suspect ink samples. Thank you for now.